So let's say we start from the Leslie's cube. Now, Leslie's cube. Now you take note that a Leslie's cube has 4 important sides. It's supposed to, a cube has so many sides, but it has 4 important sides, and these 4 important sides are made up of just 3 important colors. It's just 3 colors that we are focused our attention on: the black, the gray, and the shining or silvery surface. The black, the gray, and the shiny or silvery surface. Now, what does this Leslie cube do? This Leslie cube is more about, it's more focused on the aspect of radiation. Now, we want to know which one absorbs heat, is a good absorber of heat, which part of the Leslie cube is a good absorber of heat, which part of the Leslie cube is a bad absorber of heat, and which part of the Leslie cube is a good reflector of heat. So now let's assume that this is our Leslie cube. Our Leslie cube is like this. It's just like a cube. We'll draw a cube, and after we draw the cube, we'll pour hot water. Hot water is poured into the Leslie cube at this point. So hot water is poured into the Leslie cube, and when hot water is poured into the Leslie cube, you see there's a device called a thermopile. This is a thermopile. So the thermopile connected to a galvanometer is placed in front of the Leslie cube. When it's placed in front of the black surface, because the hot water was here, so what makes the thermopile or makes the galvanometer to deflect is because of the presence of the hot water that is delivered into it. So when the thermopile was placed in front of the black surface, it was observed that the deflection was very high. I said when the thermopile was placed in front of the Leslie cube, it was observed that the deflection was very high. When the thermopile was placed in front of the gray surface, the deflection was not as high as the black. But when the thermopile was placed in front of a shining surface, the deflection was low. So when it was placed in front of a black surface, the deflection was very high. And what does that mean? It means that black surfaces are good radiators of heat. And this is black surface, black bodies are good radiators. They are good radiators. The first one, they are good radiators. They are also good absorbers. They are good absorbers of heat, and they are bad reflectors. So I said they are good radiators. They are good absorbers, and they are also bad reflectors. When we looked at it, we said the gray surfaces, their form of radiation was second. So the black surfaces were first, the gray surfaces were second, then the shining surfaces, from what we were able to observe, the shining surfaces were bad radiators. Number 1, they are bad absorbers. Number 2, and they are good reflectors of heat. And in this aspect, I was able to say that that's why in a hot weather you don't put on a black shirt. You don't put on a black shirt in a hot weather. Rather, you put on a white shirt in a hot weather, so that the white bodies tend to reflect the heat, while the dark bodies tend to absorb the heat. And you also know that the reason why you feel warm is not because of the clothes you put on, but rather because of the air that the clothes traps. That is why you feel warm. So these are some of the things that you also need to consider. That black surfaces are good absorbers of heat. They are also good radiators of heat. They are bad reflectors of heat. Gray surfaces, they are the second, while the shining surfaces are bad radiators. They are bad absorbers, and they are also good reflectors of heat. Black surfaces are good radiators of heat. They are good absorbers of heat, and they are bad reflectors of heat. Gray surfaces were the second, deflection were not as high as the black surface, and the shining surfaces are bad radiators of heat, and they are bad absorbers of heat, and they are now good reflectors of heat. Now, apart from these aspects, we also need to understand something very important in the aspect of Thermos Flask. So we'll talk about the Thermos Flask right away. Now, in the Thermos Flask, you will understand that the thermos flask has different parts. So it has different parts. Let me just take it step by step. But the essence of the thermos flask is that it conducts the 3 types of transfer of heat. So it performs the 3 types of transfer of heat. So it performs conduction, it performs convection, and it performs radiation. So it does not just perform conduction, it performs convection, and it also performs radiation. So you take note of this, that it performs conduction, it performs convection, and it performs what? Radiation. So if the thermos flask performs conduction, convection, and radiation, you also need to take note that there are so many parts of the thermos flask. You talk about these 3 parts now. You have the double-walled glass vessel, the double-walled glass vessel, the double-walled glass vessel / the vacuum. Now we talk about the silvery surface. How does it perform heat transfer? Silvery surface. Then you also talk about the cork stopper. The cork stopper. So we have 3 parts now. We have the double-walled glass vessel / the vacuum. We have the silvery surface. Then we have the double cork stopper. Now this double-walled glass vessel / vacuum performs heat transfer via conduction and convection. Vessel that you see here / vacuum performs heat transfer via conduction and convection, while this silvery surface you are seeing here performs heat transfer via radiation. So it prevents the transfer of heat via radiation. The double-walled glass vessel / vacuum prevents heat transfer via conduction and convection, because we know convection has to do with convectional current and conduction has to do with contact, direct contact with the surfaces, if it is either solid or liquid. While in the aspect of the silvery surface, it prevents heat transfer via radiation. Then cork stopper prevents heat transfer via convection and evaporation. This is what I wanted to see in your test. So you take note that the thermos flask is performs the 3 types of transfer of heat, and this includes conduction, convection, and radiation. The double-walled glass vessel is involved in preventing heat transfer via conduction and convection. The silvery surface prevents heat transfer via radiation, while the cork stopper prevents heat transfer via convection and evaporation. Take note of this.